Let's configure DHCP for IPv6 step by step like a real network engineer. Welcome to this explainer. Today, we're going to break down exactly how DHCPv6 automatically provides IPv6 addressing and network settings to devices on your network. Now, if you're coming over from IPv4, IPv6 brings some pretty wild new concepts to the table, like devices actually assigning their own IP addresses, but we're skipping the heavy theory today. We're going to focus purely on the practical Cisco iOS commands you are actually going to use in your networking labs and in real enterprise environments.
Here is our roadmap for today. 1. IPv6 routing and interfaces. 2. Configuring stateless DHCPv6. 3. Configuring stateful DHCPv6. 4. DHCPv6 relay agents, and 5. Verification and troubleshooting. Let's get right into it.
Section 1. IPv6 Routing and Interfaces.
Okay, let's dive into this. Before we can even think about handing out IP addresses to clients, we really have to get our foundational steps set up on the router. So our absolute first step in global config mode is typing IPv6 unicast routing. I want to emphasize why this specific command is a mandatory first step. By default, IPv6 routing is just totally disabled on a lot of Cisco routers. If you skip this, your router simply won't route IPv6 packets. And critically, it won't send the ICMPv6 router advertisement messages that your entire DHCPv6 setup completely relies on. It is literally the most common mistake beginners make, so definitely lock this one in your memory.
Next up, we need to prep the specific router interface that actually connects to our clients. So we enter interface config mode for gigabit Ethernet 0/0. Here we're assigning the initial IPv6 global unicast address to the router interface itself. In this example, that's 2001:db8:1:1/64. And finally, we wake the interface up with the no shutdown command. Now our router has a pulse on that network segment. Keep in mind, the second you assign that global unicast address, the router also automatically generates a link local address for this interface, the ones typically starting with FE80. That automatic link local address is absolutely vital for the underlying neighbor discovery process we're going to rely on later.
Section 2. Configuring stateless DHCPv6.
Now that our foundation is solid, let's transition into our first major configuration method, stateless DHCPv6. This method is incredibly popular, mostly because it's perfect for deployments where you just want devices to connect super fast with minimal overhead. So what does stateless actually mean here? Well, in a stateless setup, the client literally generates its own IPv6 address using a process called SLAC. That's stateless address auto-configuration, just by listening to the router's advertisement messages. The client takes the network prefix the router sends, mashes it up with its own interface ID, and boom, creates a unique IP. So the DHCPv6 server is completely hands-off when it comes to the IP address itself. Its only job is to hand out the other necessary network details, like your DNS server address and your domain name.
So let's configure that right now. Step 1 is creating the pool using the command IPv6 DHCP pool, followed by whatever we want to name it. Let's go with IPv6-stateless. Once we're inside the DHCP config mode, we just populate it. We add our DNS server. We're using Google's public IPv6 DNS here, 2001:4860:4860:8888. And we set the domain name to company.local. Now, notice something missing. We didn't define a range of IP addresses here, and we didn't specify a default gateway. If you're used to IPv4 DHCP pools, I know, this looks super weird at first. But remember, the clients are handling their own IPs via SLAC, and they just automatically use the router's link local address as their default gateway.
But listen, just creating the pool isn't enough. We have to actually apply it to the interface facing our clients. So we drop back into gigabit Ethernet 0/0. The absolutely critical command you need here is IPv6 ND other config flag. The ND stands for neighbor discovery. Setting this flag actually modifies the router's advertisement message to basically tell the connected clients, hey, figure out your own IP address using SLAC, but make sure you check in with the DHCPv6 server for the other additional config info. See how that naming makes perfect sense? Finally, we just attach the pool we just built to the interface using IPv6 DHCP server IPv6 stateless.
Section 3. Configuring stateful DHCPv6.
All right, let's shift gears completely to stateful DHCPv6. While stateless is amazing for speed and simplicity, stateful is the method you're going to choose when you need strict administrative control, auditing, and logging in your enterprise. To contrast this directly with SLAC, a stateful DHCPv6 server acts a lot more like the traditional IPv4 DHCP you might already be used to.
The server directly assigns the IPs to the clients from a predefined pool, and it meticulously tracks exactly which client has which address, managing those lease times just like in the old IPv4 days. And this brilliantly illustrates the core mechanical difference on the router interface between these two methods. On the left, we have that other configuration flag, or O flag, that we just used for stateless. But on the right, we have the managed flag, or M flag. The command IPv6 ND managed config flag is the exact trigger that tells clients they must be managed. It explicitly instructs them, do not use Slack for your IP. Go get your entire configuration, IP address included, directly from the DHCPv6 server. Both of these flags are broadcast out to clients inside the router's ICMPv6 router advertisement messages, so they dictate exactly how the client behaves the second it joins your network.
Let's build a stateful pool so you can see this in action. We create the pool, this time naming it IPv6 stateful. Now, look closely at step 2. This looks pretty similar to our last setup, but importantly, it includes the address prefix command. In this case, 2001:db8:10::/64. This command is literally the heart of a stateful pool. It's the direct equivalent of the network command in an IPv4 DHCP setup. It designates the exact block of allocatable IPs the server is allowed to actually hand out to requesters. Then, just like before, we toss in our DNS and domain name.
Next, we're going to apply this to a different interface, Gigabit Ethernet 0/1. Here is where we explicitly type out IPv6 ND managed config flag to enforce that strict stateful managed behavior we just talked about. Once that flag is set, we bind our new pool to the interface using IPv6 DHCP server IPv6 stateful. And there you have it. With just those 3 simple steps, your router is now actively managing and tracking IPv6 leases for that entire subnet.
Now, what's really interesting is seeing the whole picture at a glance. I'd actually invite you to pause the explainer right here for a second and just analyze these complete practical configuration examples side by side. Notice how they both require that foundational unicast routing to be turned on. They both require creating a dedicated pool. But look right there in the middle section, see how stateful requires that address prefix within the pool to hand out IPs, while stateless just leaves it out completely, leaning entirely on Slack? And critically, observe the different neighbor discovery flags applied at the interface level at the very bottom, the other config flag versus the managed config flag. It's like a giant puzzle, and these are the pieces.
Section 4. DHCPv6 Relay Agents. Moving on, we really need to address a super common real-world scenario. What on earth do you do when the DHCPv6 server sits on an entirely different network than your clients? Because let's be real, enterprise networks don't usually put a DHCP server on every single VLAN, they centralize them. But routers naturally block broadcast or multicast DHCP discovery requests from crossing over network boundaries. The fix? We use a relay agent. If you're an IPv4 veteran, this is the exact equivalent of the IP helper address command. You simply jump into the interface facing your clients and input IPv6 DHCP relay destination followed by the IP address of your remote DHCPv6 server. Boom! This automatically grabs those local client multicast requests and forwards them straight to the server on the other subnet. Easy!
Section 5. Verification and troubleshooting.
Let's move to the real test and see how this builds into our daily ops. Because configuring the network is only half the job, right? Now we have to validate it. Here are your core show commands. Show IPv6 DHCP pool is going to give you the stats and utilization on the pools you just built. Show IPv6 interface brief and show IPv6 route are there to confirm your foundational interface and routing setup. But I want you to note especially that show IPv6 DHCP binding is your absolute golden ticket. For stateful configurations, this command will definitively prove if addresses are successfully being assigned. Oh, and here's a fun technical nuance. In IPv6, it tracks these bindings by the client's DUID, that's the DHCP unique identifier, rather than just a simple MAC address. It provides way better tracking for modern devices that have multiple network interfaces.
Now, if things aren't working, hey, it happens. Don't panic. Here are your handy troubleshooting tools. Use ping IPv6 to verify your basic end-to-end connectivity across the network. Use show IPv6 neighbors to verify the neighbor discovery process is actually functioning on the local link. Seriously, if you're from the IPv4 world, this command completely replaces the old show ARP command, proving that your layer 2 to layer 3 mapping is working via ICMPv6. And importantly, if you make a typo or totally botch your pool setup, you don't have to start from scratch on the whole router.
Just use the no command, literally no IPv6 DHCP pool followed by the name, to neatly tear down that specific pool and rebuild it cleanly.
Before we wrap up, let's quickly summarize the core best practices from modern IPv6 deployments, straight from our source text. Number 1, always stick to /64 subnets on your client interfaces. Why? Because this specific prefix length is strictly required for Slack to function properly in your stateless environments. It literally needs exactly 64 bits for the network and 64 bits for the host ID. Always document your DHCPv6 pools so your whole team knows what ranges are in use. Ensure your DNS is configured correctly so users aren't just staring at IP addresses all day. And finally, architect your network smartly. Use Stateful DHCPv6 when you absolutely need strict address control, and lean on Stateless DHCPv6 for simpler, much faster deployments.
I want to leave you with this provocative thought. Does your network truly automate IPv6 addressing? Seriously, think about the sheer scale of IPv6 for a second. Think about the manual labor, the nightmare of potential IP conflicts, and the administrative headache of statically assigning everything on a network that uses massive 128-bit addresses. No way, right? What we just walked through today is exactly how DHCPv6 automates and simplifies network administration, taking that massive, impossible burden completely off your shoulders.
Practical IPv6 configuration skills are essential for modern networking. If you can master these practical steps, you are well on your way. Thank you for watching. If this explainer helped you understand DHCPv6 configuration, please like this video, subscribe to the channel, and turn on notifications for more practical networking lessons.